So one thing you can be sure that a large language model can help you achieve is to be able to write better English. So if you have some text that you want ChatGPT to proofread, to check the spelling, to check the grammar, to check the meaning for clarity, to transform your text from a regular tone to a formal tone, ChatGPT would be more than happy to do that. So I asked ChatGPT the following question: can I use ChatGPT to proofread a letter I'm writing to my manager or to my professor? And ChatGPT answered, definitely, you can use ChatGPT to proofread a letter you're writing to your manager, to your professor. As a large language model, one of my capabilities is to check spelling, to check grammar, to make general suggestions to improve the clarity of your writing. Start by drafting your letter. If you ask ChatGPT to write the letter for you, you see that it will include lots of things that probably you don't want to include in the letter that you're sending. So probably it will create a letter that doesn't really make sense or is not relevant to you. So you start by drafting the letter, and then you ask ChatGPT to proofread it. You can ask ChatGPT to change the tone, and ChatGPT would change the tone of the letter, give you a formal version of the letter, would make suggestions that would fix the grammar, the punctuation, and the clarity of your text. Transforming the software development lifecycle. So if I want to integrate artificial intelligence as part of in my software development, we spoke earlier that Codex is an AI that is trained on programming languages. So you can ask Codex, or you can ask ChatGPT in general. These are trained on lots of code. So you can ask it questions about the code, how to understand, how to document, how to transform the code. The same way we said you can transform regular text. ChatGPT can transform code, can give you a better version of the code, a more performant version of the code, can reason about the runtime of the code, can detect errors in the code, can help you fix the code. You can also ask it if it has any suggestions for test cases about how to test the code. Incorporating AI in the software development lifecycle can have transformative impact on the entire process. If you have an AI that is trained on software design, on software code, on software architecture, you can use it to help make suggestions about how to implement a better design, or how to suggest a better architecture. And it would help automate some of the tasks. For example, if it manages to generate and automate test cases, at least the generation part, we're going to talk about how to use ChatGPT to do those simple tasks. So this will result in a more efficient way of writing code. And as long as you are checking the code that the AI is suggesting, and you're reading the explanations that it's giving, as long as it is making sense. You can also couple it with other sources, like you have a good book or a good reference, to make sure that you're not only relying on one source. So let's look at some of the ways AI can affect the development lifecycle. A large language model such as ChatGPT can be used for requirements analysis to understand the user requirements. So these are presented in natural text, and the AI can help analyze the features, to understand the features. So you can, you as a programmer, if I have an AI that I can ask questions about the software requirements, and if this AI can also come up with questions to ask the users or other stakeholders how to and gather information and make it available. So you'd ask the AI what about this feature, and what are the functional requirements that should be implemented, and what is the best way to implement those. And the AI can suggest or can help suggest a good design or help suggest a good architecture, and it can help make your task easier. AI-driven code, so we're going to use an extension for Eclipse. We're not going to use Codex and GitHub Copilot, and we're going to use it to make suggestions about the code, to explain the code, to suggest fixes for some of the errors of the code. And so this AI, when it can perform code reviews, and it can detect potential bugs, and it can suggest best practices, this will make your task much easier. It will help you write better code in very little time. Incorporating AI in the software development lifecycle can lead to faster development cycle and reduced manual error, the code quality, and the user requirements, better understanding and organization of user requirements. Also remember that the AI is improving, let's say. So at some point it might be able to generate code that is flawless, or code that will not require any review before incorporation, before using it in your software. But we're going to see that for the simple tasks of creating simple functions, the AI is going to do an excellent job. If the task becomes more complicated, the AI will not perform as expected, and you will see it do lots of mistakes. Well, at least it's going to give you a good starting point. So it's going to suggest some of the things you want to use as part of your solution, but will most likely not do the part that requires the analysis, the way you're going to think how to come up with a good the part that requires critical thinking is going to remain for the programmer to do. Also think about the biases of the code, and whether you are allowed, so if there are any ethical implications, whether your company or your school or the exam allows you to use AI before you decide to use AI. Let's look at an example of a prompt that we're going to use to document the code. Let's switch to the in the context of the given Java class denoted by class, I want the documentation, the Java doc style, for the Java type, Java method, identified as name. So you see this prompt is designed to be reusable. You can use it with another class, with another method, and you just change this part. This was this prompt is mainly part of the AI extension we're going to be using. This AI assist that we're going to be using. So if you examine this prompt, we are giving the prompt by itself is not as simple as it looks. So the AI now has to recognize the class, the method, and the block of code that I wanna document. Is gonna analyze the code and is gonna give me an explanation of what the code is doing, and I'm adding more constraints. I'm saying that the response should not consist of the entire class, the entire method declaration. I want to only see the javadoc command and make sure that the documentation is concise, is as resumed as possible, is as concise as possible, and also if the documentation for this method exists, updated in line with the current documentation. If I give this prompt to GPT 3.5, you'll see that GPT 3.5 will not do a good job. So let's navigate to ChatGPT, and ChatGPT is going to ask me to log in. And then it's going to take me to chat.openai.com. Because I have the Plus subscription, I can switch between GPT 3.5 and GPT-4. The GPT-4 is going to give me more options, and it's the most powerful, it's more powerful than GPT 3.5. Let's try to give this prompt to GPT 3.5. So in the context of the class, generate the javadoc documentation. Make sure that you only return the javadoc command in a resumed and concise way, and updated online in line if the So while it generated the javadoc for the entire class, including the method that I'm looking for, computes the sum of numbers from 1 to some specified total size. Using parallel streams, returns the sum of numbers. It didn't really follow the instructions that I gave it. It didn't understand that it was supposed to only generate the javadoc for the method, not for the entire class, and it wasn't supposed to return the entire class and the entire code, because I gave it instructions not to do that. So let's try this same prompt with ChatGPT 4, see if I get a different result. See, it was easy to, so this was probably the first example we run in ChatGPT, and it wasn't hard to interact with this ChatGPT. And let's try GPT-4, the default mode, and give it the same prompt, and see if it's gonna understand what I wanted to generate. Certainly, here is the documentation for the method from the class parallel add. Remember, I asked it specifically to generate the documentation of the method from the class and not to return the entire class. So see, it gave me the computes the sum of numbers from 1 to the total size using parallel stream. It leverages the parallel processing capabilities to enhance the performance in summing large sequences of number. The total size of the range for summing is by the static constant total size. So you're summing the numbers from 1 to total size, and total size is a global constant. So you see, ChatGPT 4 was able to make sense of my query much better. And we said not to underestimate how restrictive this this prompt is. It not just expected the model to recognize the actual prompt and to write a description using, so in the Java doc, it constrained the prompt in a way that ChatGPT 3.5 was not able to make sense of the instructions. So if the first prompt needed ChatGPT to return a very resumed and he didn't want it to explain much. It just wanted one-line explanation, typical Java doc style. So now how about I wanted to give me an explanation of the code. So this longstream.range closed 1 to total size dot sum you're asking the model to do the sum of the numbers from 1 to some upper limit using parallel streams, and you know very well that the sum of I taking values from 1 till n does not need parallel stream, so there is an order of 1 equation that you can use. Let us see if the model can detect that. But the original intent of this exercise is to do the sum of some large number, a large array of numbers or a large list of numbers, not the numbers from 1 till n. Let's see a different version of the another prompt that I can use to get a comprehensive explanation of what the code does. Explain the different components in this code snippet and give me a detailed explanation of what's going on, of the functionality. And I want you to explain the concepts or the techniques that are used in the code. So let's try this other prompt with ChatGPT. So this is actually, let's I had another example about the previous one, the exact same prompt where we replaced the class with where we use another method to get the Java doc explanation of the method. Let's take a second to look at the code. The code declares an array of numbers, and it's a large array of numbers, so you have 1 million or 10 million elements in the array, and you want your code is the intention is to actually do the sum of these numbers. And I'm using ChatGPT to document this method. This method does the sum using a thread pool. So it creates a runnable, and each runnable represents a task. And each task is going to be assigned to a different CPU. And each task is going to take a chunk of these numbers and do the sum on a local sum. So we declared an array sums of threads, and each value of the array is going to represent the sum of the numbers for that task. And I created as many tasks as I have CPUs, and I used a fixed thread pool with that many workers, and this thread pool is gonna assign these tasks to the available CPUs and execute the task of doing this sum of numbers in a multi-threaded way. And then I'm gonna await for the task to finish, and then I'm gonna return the total sum, which is the sum of all the intermediate sums. So let's see if ChatGPT can explain the code to me, or can reason about the give me a Java documentation that explains the code in the way this so we're not going to use GPT 3.5 for most of these tasks, but you are free to try whichever version of the model that you have. So let's see what this, how the model was able to make sense of the code. Computes the sum of integers in the array nums using the fixed thread pool. This method divides the task into chunks and assigns each chunk to a separate thread. The number of threads is the number of available processors, and the chunk size is determined by dividing the total size of the array by the number of threads. It leverages the executor services to manage the thread pool and coordinate the summation. So it's a decent explanation of what the code does. Let's see if I ask it to can you please give me a detailed explanation of the previous method? Is to compute the sum of integers stored in a large array called nums. This sum executes in parallel using multi-threading to increase the computational efficiency. Here is a step-by-step explanation of how this method works. In inner class, my task implements the runnable interface, and each instance is a task that will do the sum of a chunk of numbers in the array. And the executors.new, so a fixed thread pool with the number of threads is determined by the number of the available processors on your machine. The array is divided into chunks. Each chunk size is computed as the total size divided by the chunk size. For each thread, a task is created and executed by the thread pool. It sums into an array and stores the results in the sums per thread array, which is indexed by task number -1. So for each task, the corresponding sum is the order task number -1, and then it awaits for the execution. Then it does the sum consideration. The concurrency uses the executor services to manage the parallel execution, dividing the work among the among the available CPUs. It can significantly reduce the sum, and then it awaits on the termination if it times out, interruption, exception. And so you see there, so you can understand what the code is doing from a document like that. So it gave you all the details that you need to understand the code, right? Let's continue with this second example. Can you please explain, can you give me a comprehensive explanation of this code? I want to understand the concepts and the techniques used in this code. Let's change this code to do Let's try GPT 3.5, see if it can give me a detailed explanation. So GPT 3.5 was not as good as understanding the complicated prompts. So you'd assume that GPT-4 would do a much better job if you give it something that requires lots of thinking, lots of reasoning. But the GPT 3.5 can give you a decent explanation. So give me a comprehensive explanation of the code. The provided code computes the sum of a sequence of numbers using streams and parallel processing. The static long sum is a public static method, returns a long value. Long.range clause generates a stream of long numbers from 1 to total size. Let's ask it. So you see, it can reason about the code. You can spend some time. It's explaining stream. Stream is a powerful abstraction that allows you to process sequences in a declarative manner. You can process it in sequential or in parallel. Take advantage of a multi-core processor for parallel processing. By invoking parallel, you indicate that you want the execution to happen concurrently on multi-threads, which can result in improved performance for tasks that can be divided into smaller subtasks. Generates a stream of sequential sum, parallel switches to a parallel stream, sum, computes the sum. So you can, let's see if ChatGPT 3.5 can give us a more performant. What is the complexity? So let's change this from parallel to sequential. And say, what is the complexity of the code provided below? And can you suggest a better another version that performs better? The code provided computes the sum is order of n. And if you're looking to more efficient way to compute the sum of numbers from 1 to n, especially for larger values of total size, you can use the formula, which is the sum I taking values from 1 till n is n times n plus 1 divided by 2. This one is order of 1, the first one is order of n, and it gives you another version of the code where the sum of numbers from 1 till total size is actually total n times n plus 1 divided by 2. So GPT 3.5 was able to answer the question. So you'd expect GPT-4 to also be able to answer this same question. So we said if there is something you can expect from these large language models is to be able to take some English text and rewrite it. So how about refactoring the code, transforming the code? What is code refactoring? Code refactoring is transforming the code while not changing its meaning. So you don't want to change the behavior of the code, but you want to make improvements on the code. You might want to consider writing code that is easier to read, easier to understand, add some documentation, make the code more performant, more maintainable, more readable, more so simplifying the code, adding documentation, or writing another version of the code that is more performant, that is more readable, are all part of the transformations you do on Java code. Let's use the following prompt to see if we can bring some performance to the overall quality of the code. In the context of the source code provided with the class, the source code labeled class provide a refactored version of the code snippet labeled snippet. Focus on optimizing my code. I want to write a more performant version of the code. If the code does not require refactoring, you can respond with the message, the code does not require refactoring. Keep your explanation concise and compact. Do not print the content of the class, just the modified code snippet. And this is we just did this exercise, so we're doing the sum from 1 till total size, and we want to see, so let's quickly give that to GPT-4 this time, because it's a complex prompt. And it suggests again, so you want to use the formula that given a number n and you're doing the sum of I taking values from 1 till n, the sum is equal to n times n plus 1 over 2. And it explains that this changes the complexity from order of n to order of 1, which will bring noticeable improvement for larger values of n. Let's say I want to persist, I want to ask it to rewrite the same code, but I want it to perform the optimization using streams and parallel streams. So I can ask the model to redo the exercise. By this time, I wanted to rewrite this query using streams and parallel streams. So the original one was the imperative style of computing the sum. Now I want to write it the declarative style, and I wanted to give it to me with using streams, parallel streams, and the reduce operator. So here you go, the range clause.parallel.reduce, the sum operator is commutative and associative, so there is no problem executing in parallel. Reduce takes the identity and the binary operator. The integer.sum takes two integers and returns their sum, and this rewrites the sum using parallel streams and the reduce operator. It gave you a good explanation, so you can perform the optimization using the reduce sum in parallel, and the parallel streams, the operation is distributed across the available processors, which reduces the computation time. However, noting that parallel processing overhead may not always result in better performance, and it reminds me that there is a simple formula that I can use to solve my problem. But remember, the intent was to sum sum an array of random numbers, not necessarily the numbers from 1 till total size. But in all cases, you see that the model can perform decently. Even it can bring to your attention that you probably are trying to do this, and it will suggest a fix. To go back to our original problem where we were doing the sum of an array of numbers, and the number was very large, so it had a few million integers in the integer array, and we were doing the sum in sequence, and we want to ask the GPT-4 if it can suggest a more performant way of writing the code. So you guessed that by now it's going to suggest probably using streams, but can we get it to write it using the thread pool that we saw earlier? And we're going to see that it's not going to be able, it's going to be able to write it as a stream expression, but most likely is not going to be able to give the other version of the code in a way that will run. So let's try to give it this prompt to GPT-4. In the context of the given code snippet and the class, the sum of the numbers in an array, we're dealing with a large array, so the task can be performed with parallel streams, which will enhance your performance. Integer stream dot of an array of number, arrays dot stream, and an array of numbers dot parallel switches to a parallel stream and then computes the sum in parallel. The refactor code leverages the parallel streams that sum the elements in the array. In parallel processing, this will lead to performance improvement in a multi-core machine. By using parallel streams, the operation is distributed across the available cores, reducing the computation time for large array, and it's suitable optimization considering the parallel nature of the summation task. Let's ask it if it can redo the previous tasks using runnables and using a thread pool. Can you please rewrite a multi-threaded version using the runnable class and a thread pool to execute in parallel? He probably was able to learn it from my code, or did I think at some point I asked GPT 3.5 to give me a version of the code that does that, and it performed very poorly. Let me show you GPT 3.5 how GPT 3.5 suggested I wanted to create a task for every number I'm adding, and it suggested I want to declare a final version of number so that I can add it. Then it forgot that the sum is not final and it needs to update it. And also it was performing by accessing this shared variable on multi-threads, it was doing so the code will not run properly. It will result in data races. But it gave me the different parts of the code. I want to use a fixed thread pool with a number of threads that is equal to the number of CPUs that I have, and I want to divide. So I don't think it even suggested dividing the task into chunks to do the sum, and it suggested doing something like that, which doesn't work. So which won't even compile. So if I try to compile this code, if I try to run this code, it will not run properly, because the sum has to be final first, and second the sum is here fixed to be a global variable. So had the sum be a local variable, this code won't compile, and this will result in data races because the shared variable is being updated on multiple threads. But if you look at GPT-4 was able to write a decent version of the code. So for each runnable, I'm going to do a chunk of the code from let's paste this in the IDE. So let's copy the code into the Eclipse IDE and try to run the code. I did that to save some time. And this is the method without any changes. So it's doing exactly what we were doing. So we implemented a runnable for each of the tasks. I'm going to do the sum of the chunk from the chunk size till from the lower limit till the upper limit of the chunk size. I'm going to add the nums of I in a local variable, sums per thread, and then at the end I'm going to do the sum of these, and let's compare the runtime for the one that performs in sequence versus the one that runs in parallel. You see the code that GPT just gave you, the code that GPT just gave me runs and performs much better than this serial method. Let me pause for 1 second to get the results. So here you go. It took around probably a minute or so to execute both. They both computed the sum correctly, so the sum of numbers is equal to that much, and the serial loop, so this parallelization executed 2 times faster. So you'd expect it to perform much better. So it's using distributing the sum on the available processor, so you'd expect it to perform much better than the serial one. But here you go. This is the code that GPT-4 just wrote, which is a parallel version of this serial sum that uses multi-threading, and it uses the fixed thread pool to compute this sum on multi-threads and then compute the total sum of the subsums in sequence. So this was using the ChatGPT, the interface, the web interface that ChatGPT has, but it's not the only way to interact with ChatGPT. So you can interact with ChatGPT by integrating it into your app using API calls. Let's look at an example of a plugin that integrates the ChatGPT functionality within by making API calls. This Assist AI is a plugin that you can download from the Eclipse marketplace. And if you look for AI Assist, you can download the plugin. This is the GitHub. So the AI Assist, the ChatGPT plugin for Eclipse that you can install to get AI to get OpenAI and ChatGPT help by writing when writing the code. To be able to use the plugin, you need to generate an API key for OpenAI, and it won't allow you to use GPT-4. If you try to use GPT-4, the requests are not going to go through. And the API key you need to generate from the website. The platform OpenAI.com accounts API keys will let you generate keys. You're going to need to generate a new key and then get the and then bring the key. I'm not going to be using this key. You keep the key private, and then you're going to need to include with every request that your Assist AI or any plugin you're going to be using is going to include a key to the OpenAI website for authentication and authorization. We looked at some of the prompts that this plugin has, such as discuss the code, document the code, understand the errors and find some solutions for your code, refactor the code, or perform some test cases on the code. Let's look at some of these examples from within the IDE, how you can use AI integrated in the within the IDE to help you writing your code. Let's say I want to use the plugin that we just installed to see if the ChatGPT can help me understand what's wrong with this piece of code. I'm trying to type as a function this lambda expression that maps a string s into the canonical path from this relative path s. And saying this code throws an input-output exception that you don't handle. So the signature of the function interface does not allow you to throw an exception. It's not part of the signature. So you need to handle the exception in the code. Let's see if I want to discuss the code. So IDE sent a request to OpenAI with your key, and your key is authenticated and authorized. So it asked it, want to discuss the code, and ChatGPT replied, ready to discuss the code. What would you like to ask? I want to ask ChatGPT, what is the issue with my code? Can you help me fix it? The issue with your code is that you have a compilation error at line 10. The unhandled exception of type input-output exception. The method throws in potential input-output exception and you have to handle it. So for you to be able to type it as a function of a string and a string, you have to handle the exception. You can throw a runtime exception, but you cannot throw a checked exception. So let's take the code, see if it actually works. And the code GPT 3.5 gave me works perfectly, so you expect GPT 4 to give you even go. Let's ask ChatGPT to catch an input-output exception and throw an unchecked exception. It must be quote or declared. Here's the refactor method. Try catch an input-output exception, throw a runtime exception, error getting the canonical path and the input-output exception. Let's look at this second example where we're going to use the Assist AI plugin to see if we can get support from ChatGPT 3.5 from within the IDE to see what's the issue with this code. So here I'm asking the stream API to generate an infinite stream, and then I'm triggering the evaluation, collecting in a list and outputting the elements into the console. But if you remember, this generate method with the supplier of t generates an infinite stream of string, an infinite stream of numbers. So this is eventually going to result in an infinite loop, and this is going to result in an out-of-memory exception. So the system is going to run out of memory as it's evaluating this infinite stream of strings or infinite stream of numbers. So let's see if the GPT 3.5 can detect that and can explain to me what's wrong with this code. So let's go to Assist AI and ask it to discuss the code. Let's see, do you see any issues with my code? It suggests that I'm using the toList method, which is a terminal operation introduced in Java 16. So the prior versions of Java will not recognize this method toList, and suggests that my stream should be written as with the collectors.toList method rather than with the toList. So you see, this doesn't really solve my issue. Let me see if GPT-4 can do a better job at detecting what's wrong with my code. There is a significant issue with your code. The stream generate method creates an infinite stream. It will keep generating values infinitely. When you call the toList method on this infinite stream, you are going to create a stream of infinite strings echo, which will cause your system to run out of memory. So you probably want to limit the number of elements in your stream using the limit method, so that you stop after 10, you don't result in an out of memory. Let's run both, see if ChatGPT 4 was right. So it suggested that the first one will result in an out of memory exception, and the second one will run perfectly. And as expected, the heap memory, so it ran out of memory, the JVM ran out of memory, and the infinite stream caused your program to run out of memory. Let's see if the second version that GPT-4 gave me, if you were to try this other method, you'll see that it will not solve the issue, so it will still I'm gonna still run out of memory because I'm evaluating in infinite stream. I'm triggering a terminal operation on an infinite stream. So GPT 3.5 was not able to resolve my issue, and my code was not fixed from GPT. But GPT-4 resolved the issue. Let's see if the code will run now. So here you go. GPT-4 knew that this supplier of T, and you're triggering a terminal operation on an infinite stream. If you remember this property of lazy evaluation of the streams, when you triggered the evaluation on the infinite stream, you resulted in an infinite loop that caused your system to run out of memory, and GPT-4 detected that you wanted to limit the number of elements in your stream so that the evaluation of your stream takes place occurs correctly. Let's look at this third example, where we're trying to concatenating a large number of strings. And if you remember, this is going to cause my program to run out of memory, because this concatenation of strings is going to always create intermediate strings. And if you remember, you should use a string builder instead of the string concatenation, which results in lots of intermediate unnecessary strings. So let's see if the GPT-4, if GPT is able to detect that. Do you see any issues with my code? There is an issue related to the performance and the memory usage. In this given code, a string object is being concatenated in a loop using the plus operator, the plus equals operator. This is not efficient when dealing with large number of concatenations. It's going to create an intermediate string with every concatenation. This will result in poor performance and excessive memory usage. You can use a string builder instead of the string concatenation. It will improve the performance because it will not create a new string every time. It will only create one final string when you invoke the toString method. So let's try to let's first run the first code, see if ChatGPT was right. That is gonna result in an out of memory error. It's been running for 2 minutes now. I don't expect it to return any result. I expect it to crash, but I don't think I'm going to wait longer, so let's try the other version of the code. And let me try the other version of the code. See, it was much more performant. So ChatGPT 3.5 was able to solve my problem. Let's look at another example. So in this example, I'm calling this recursive function f, but I'm passing f of I minus minus, and I minus minus is going to evaluate to I, so I'm calling this function f with the same I, and the base case, it will never be reached. Let's see if ChatGPT 3.5 can detect that. There is an issue with the code. The issue is the recursive method f of I. In the given code, the recursive call is not correct. The decrement operator will use the current value of I and then will decrement I. However, since the recursive call happens before the decrement, this will result in an infinite recursion. So you either want to use the postfix or you want to write f of I minus 1. And there is no need to try that. So if you try it, you're going to see that f of I minus minus is going to result in an infinite loop, which will never reach the base case. And if you want to fix it, so if your intent is f of I minus 1 or f of minus minus I to fix the infinite recursion. Let's look at this other example. So here, let's say I've written an if then else, and I wanted to include the default here. But since my if then else included every case, and the base case here, so this default return of 1 is not going to be reachable, whether I is strictly negative, is 0, or is positive, the code here will not be reached. So let's see if ChatGPT can explain to me what went wrong. The error at line 17 is caused by the presence of an unreachable code. You can just remove return 1 because it's covered in the else clause. So you see, ChatGPT is not, even though we called it a glorified recorder that's going to replay things that it has seen, but you see clearly that it can be of great assistance when you're writing your code. We're going to do one more. We're going to do one more example about generating test cases. For this final exercise, I asked the GPT 3.5 to generate the test cases using JUnit for this method stream.generate.limit.toList. And it suggested these use cases. Assert the result.size is equal to 3, and assert that result.get at 0 is equal to echo, and result at 1 is equal to echo. And then it generated a list with 0 elements, and assert true that the list is empty, and then generated a list of size 5 and asserted the size is equal to 5, and the elements from 0 to 4 are equal to the empty string. So you see that the AI can be very helpful in understanding the code, in reasoning about the code, in transforming the code. Not just that, it can suggest fixes, it can suggest some testing use cases. And if you can use the AI either on the ChatGPT interface, or you can install a plugin, and it's the same thing. The API is going to be using the API is going to be using the API calls into the and you want to make sure that you have enough users, you have enough credit to be able to use the API. So you see how much you're using from this API. You can check the how much you're going to be charged, and you can control the keys that you're using. So I hope you've enjoyed this lesson on ChatGPT and how you can use ChatGPT to improve how you write English in general, to improve how you write code. The AI can help you do finish your task much faster, give you much more insights in the code, even though the AI will not write the code for you. Even though at times we were able to get the AI to write even very complicated tasks, such as writing a multi-thread version of the serial task we were running. We expected the AI to rewrite it as a stream, as one expression, whether it's the serial or the parallel, to reason about the performance or the correctness or the different scenarios that we're going to run to when we run the code. But I believe if you try it, it's the only way to understand and see what it can do for you. Whether you have the free version and you're going to need to put more manual checking, and as these things learn and progress, you'd expect them at some point that they will be much more efficient. For the lab, we're going to do some form of an API integration, but we're not going to record the lab. So happy learning. I hope you learned something from this lesson, and good luck in your job search.